Sherlock Holmes and Watson go out on a camping trip. As they lay down for the night, Holmes looks up at the sky and asks Watson, "Tell me what you see." Watson says, "I see millions and millions of stars." Holmes then says, "Well, what does that tell you?" Watson replies, "Well, astronomically, it tells me that there are millions of galaxies and potentially billions of planets. Meteorologically, it tells me we're going to have a beautiful day tomorrow. What does it tell you?" Holmes replies, "It tells me someone stole our tent." And that is an example of logical reasoning. And we're going to start with inductive reasoning. What is inductive reasoning? Well, it's the process of making a general observation based on examples. Or you could say that it's a way of coming to a conclusion based on what you see, on what you observe. For example, if every time you wore your lucky shirt to the football game, the Raiders won, then you could reason, when I wear the lucky shirt, we win. And if you don't wear the shirt, they lose. So you say, this is a lucky shirt. Now, is that really true? Well, you could argue, well, if one time the shirt doesn't work and you wear the lucky shirt and we lose, that would be what we call a counterexample. So let's get back to the conjecture. Inductive reasoning is a generalization a generalization you believe to be true on inductive reasoning is called a conjecture. So your initial conjecture is, when I wear my lucky shirt to the football game, the Raiders win. But if I don't wear my lucky shirt, the Raiders lose. All right? Now, a counterexample is something to prove it false. You cannot really prove inductive reasoning true, but you can prove it false. How do we prove it false? We just show one case where it didn't work. So, it's a true conjecture only if it's always true. So if the Raiders really do always win when you wear your lucky shirt, then that is as far as we're concerned, it's considered true so far until you prove it false. Now, is it true, true, true? We don't know. So once a conjecture is proven to be always true, then it becomes a theorem. And we don't do that with inductive reasoning. We're going to do that later with deductive reasoning. So based on observation, we can't really say that a conjecture is always true and becomes a theorem. We can show that a conjecture is false through a counterexample using inductive reasoning. So here's a conjecture. Students who do their homework will get better grades. So if I saw all these students who did their homework and they did have better grades, that means that my conjecture is probably true. But if I saw a student who did their homework and they didn't get, in fact, if they didn't get better grades than they did before, then that would prove this conjecture false. So the inductive reasoning is a process, and what you do is you look for a pattern, all right, and list at least 3 examples. So try to think of 3 observations that you've done. And if using numbers, try setting up a table. You used input-output tables in 6th grade. Draw a picture. That's quite helpful, especially when looking for counterexamples. Step 2, you're going to make a conjecture based on the pattern that you see. What do you think is true? Then finally, test 3, you're going to test the conjecture by looking for a counterexample. So if using numbers, try more than one type of number, such as whole numbers, fractions, positive or negative. Some people forget we have negative numbers, and you can even try 0. Try drawing a picture. You only need one counterexample to prove a conjecture is false. So in this example, we're going to determine if the following conjecture is true or false. If 2 angles in a triangle are complementary, then the triangle is a right triangle. All right. Well, let's see. I'm going to throw 2 angles in there that are complementary, 45, 45. What does the other angle have to be for this to be a triangle? Well, they all have to add up to 180. So that means the other angle has to be 90. So that's a right angle, so it's a right triangle. Let's say I do 30 degrees and 60 degrees. If I do 30 for one angle, then I have to do 60 for the other, because remember, complementary means adding up to 90. Well, if all three angles in the triangle have to add up to 180, that means that third angle has to be 90. So far, based on inductive reasoning, I am not able to prove this false. I haven't found a counterexample, and it seems to be working based on the examples. Even when I do 10 degrees, for it to be complementary, the other angle has to be 80. Well, that means that last angle is going to be 90. So I tried 3 different examples, and so far it looks like this conjecture is true. Later, I can deductively prove that it is always true. But we're just using examples right now, so we're doing inductive reasoning. Okay, but based on our inductive reasoning, we're going to say we believe the conjecture is true. We cannot find a counterexample. Now, we're going to determine if this conjecture is true or false. The sum of an acute angle and an obtuse angle is 180 degrees. Well, if I do 70 degrees, that's acute. Remember, acute is less than 90, and obtuse is more than 90. And in this case, they do add up to 180. So in this instance, the statement is true. But what if I did 60 degrees and 100 degrees? 60 is acute, 100 is obtuse. They don't add up to 180. All I need is that one counterexample to prove the conjecture false. So for further reflection, if a conjecture is sometimes true, then what is its truth value? Hopefully you realize it's false. All we need is to show that it doesn't work all the time. What is a counterexample and how do we use them? We use them to test to see if a conjecture is false. And what are some strategies? Well, try more than one example. Try to draw a picture. Just try different things out and see what you can find.